Hey everyone, and welcome back. You know how much we love it when those totally random things they turn out to have this like crazy deep connection.
Yeah.
Well, buckle up because this deep dive is going to be a wild one. We're diving headfirst into the world of Philomath, and this book, it basically argues that numbers are like the secret language of the universe.
It's true.
Right? Forget just using them for counting change at the store.
Right.
Philomath says they're more like the actual building blocks of reality itself.
It really is mind-blowing when you think about it. Yeah, like we're talking about numbers not just as tools for calculation,
Right.
but almost like the DNA of reality.
Okay, well, slow down there.
So,
We've got these excerpts, right, from Philomath.
Yeah.
And they're jam-packed with these crazy ideas.
they are.
Like, get this. What if prime numbers, those mysterious numbers that everyone loves, especially in cryptography,
Right.
what if they actually hold the key to understanding how we see?
That's true.
Or how about the golden ratio? Everyone's heard of that, right?
Of course.
That mathematical superstar that pops up everywhere.
Everywhere.
Not just in art and architecture, but in our bodies too.
It's incredible. And that's not even scratching the surface. We're going to talk about how numbers might act like waves.
Okay, hold on.
Yeah.
Numbers like the ocean.
Yes, like waves.
Okay.
We'll explore how numbers and geometry are like two sides of the same coin.
Right.
And get this, we might even talk about the possibility that music can create actual geometric shapes.
Okay, now you're just messing with me.
I'm serious, it's all in there.
So you're saying that all these different fields,
All connect.
they're all speaking the same language.
Right.
We just haven't been able to understand
You're
it
finally starting to, yeah.
until now, maybe.
Yeah.
So to kick off this crazy numerical adventure, let's start with something Philomath calls the digital newt. Have you ever even heard of this thing?
Oh, yeah. It's surprisingly simple, actually. You take any number, right? Any number at all.
Okay, give me any number.
Okay, 5,432.
Okay, 5,432. Got it.
So you add up each of those digits.
Okay.
5 plus 4 plus 3 plus 2.
Okay.
And if you get a two-digit number, which we will in this case, you just keep adding those digits together until you're left with one single digit. And that final digit, that's your digital root.
Okay, I mean, I understand the calculation, but what's so special about this digital root thing?
Well, what's fascinating is how this super simple operation can uncover these hidden patterns in sequences of numbers. Like, Philomath talks about this visual representation they call the basic D circle. And basically, the digital root helps us understand the symmetries within this circle.
So it's like the digital root is like a secret decoder ring for the hidden language of numbers.
Exactly. Like, for example, the numbers 3, 6, and 9, when you put them into this D circle, they form this repeating pattern that has these really unique properties. It's kind of like, learning the alphabet before you can read.
Okay.
The digital root is like this fundamental concept that helps us unlock these deeper meanings.
Okay, my mind is already kind of blown.
Yeah.
And we haven't even gotten to the really good stuff yet.
I know.
Like prime numbers. I mean, these things have fascinated mathematicians forever.
Oh, yeah.
But Philomath takes it to a whole other level.
It does. They do seem random, right? You look at the number line, they're just kind of scattered all over the place.
Yeah.
But when you start to visualize prime numbers geometrically, suddenly all these hidden patterns and relationships start to emerge.
Whoa, really?
Yeah. Like, one of the most captivating examples is something called the Ulam Spiral. So picture this. You've got the spiral of numbers, right?
Okay.
And the prime numbers within that spiral, they mysteriously align themselves along these diagonal lines.
No way. Really?
It's true, yeah.
That's crazy.
It's like there's this invisible hand organizing them.
Yeah. It's like, what is going on?
I know, and it gets even weirder.
Weirder.
Yeah. So recent research has found this really strange quirk about prime numbers.
Okay, what? Tell me.
They seem to, hate to repeat themselves. They don't like to have the same last digit as the prime number that came before them.
So it's like there's order within the chaos. Like a secret code, but with prime numbers.
Exactly. And this isn't just some mathematical theory, okay? Some researchers believe that our brains, they might actually use similar patterns found in prime numbers to process visual information more efficiently.
So you're saying that understanding prime numbers could be the key to unlocking, the secrets of how we see the world.
That's what Philomath is suggesting, yeah.
That's incredible. Okay, we've got digital roots, prime numbers. We got to talk about another mathematical rock star,
Who's that?
the golden ratio, also known as phi.
Phi, yes.
It's like this celebrity ratio, always showing up in the most random places.
Well, by random, you mean like everywhere, right?
Right.
Spiral of a nautilus shell, the arrangement of seeds in a sunflower.
Right, exactly.
What's really mind-blowing about the golden ratio is its connection to the Fibonacci sequence.
Oh yeah, Fibonacci, that's the one where you like add the two previous numbers together to get the next one.
Exactly. Yep. So 1, 1, 2, 3, 5, 8, and so on.
Right.
Now, when you take that Fibonacci sequence and visualize it, it creates this spiral that almost perfectly matches the golden spiral, you know, the one that's directly derived from the golden ratio. It's like they're two sides of the same coin.
Oh wow.
And it just further solidifies this idea that numbers really are the blueprint for the universe.
Okay, that's pretty wild. And speaking of wild, Philomath takes us on this totally crazy ride by suggesting that numbers themselves, the numbers, might actually behave like waves.
It's true.
Okay, hold on. I need a second to process this.
Okay.
Numbers, like doing the wave at a baseball game?
Well, not exactly.
Okay.
But when you dive into the world of reciprocals, basically 1 divided by any number, you start to see these wave-like patterns emerge.
Okay.
Certain numbers, when you flip them into their reciprocal form, they create these repeating decimal sequences.
Right.
And these sequences, they actually resemble waveforms.
Get out of here. So numbers are like surfing now. What is
I
happening?
know, right? But it gets even wilder. This whole wave-like behavior of numbers, it might actually connect to the whole wave-particle duality thing that we see in quantum mechanics.
Wait, are you serious? Quantum mechanics. Like the idea that electrons can be both a wave and a particle at the same time?
That's the one.
I mean, I've heard of that, but I never thought I'd see the day where numbers got in on that whole quantum dance party.
Well, get ready, because Philomath is about to blow your mind.
Oh, no. Okay, I think my brain is just starting to, like, accept this whole numbers as waves thing.
No, it's a lot.
It's a lot. But Philomath doesn't stop there. Oh, no.
Of course not.
It dives even deeper into this connection between numbers and geometry,
It does.
saying they're not even separate things, just two sides of the same coin.
Exactly. Yeah, like geometry is almost like this visual language
Okay.
that numbers use to express themselves.
Okay, I like that.
And those expressions, they get really, really profound sometimes.
And Philomath seems to think that this one number holds a lot of importance, especially in geometry. You're talking about the number 72, right?
72, yes. Philomath makes this point that the sum of the angles in a lot of polyhedra, so those are just three-dimensional shapes.
Right.
The sum of those angles is often a multiple of 720 degrees, which is just, 72 times 10.
Right, okay.
Like there's this hidden code
Wow.
within the structure of these shapes.
So 72, it's not just some random number. It's like hinting at this connection
Totally.
between shapes and the math behind them.
Exactly, yeah, and it goes on.
It always goes on.
The number 72 also pops up when you look at the geometry of a pentagon. The shape.
Oh, right, the shape. Okay, for a second I thought you were talking about like the building.
No. The pentagon, 5 sides, it pops up everywhere in nature.
It does.
Flowers, molecules.
Wow.
And 72, it even played this huge role in how ancient civilizations understood time. It's like this number, 72, it's this thread connecting math and shapes and like human history.
Okay, that is officially creepy. Like cool creepy, but creepy. But speaking of shapes with deeper meanings, Philomath talks about this other shape that I'm fascinated by it.
What's that?
The hexapentakis.
The hexapentakis,
I mean, what is that? Is that a magic spell?
Not quite, although it does feel kind of magical. You basically take a hexagon and a pentagon, you combine them.
Okay.
And boom, the hexapentakis. And the symbol, it pops up everywhere, different cultures, nature.
Yeah.
It's thought to represent this interconnectedness of everything.
So it's more than just a pretty shape.
Oh, yeah. We could be talking about shapes that encode like real truths about the universe.
Whoa. Okay, that's deep.
Well, I know. What's even crazier is that the hexapentakis comes from the golden ratio.
Really?
Yeah. And the Fibonacci spiral. Like solidifying this connection even more. It's like a visual representation of how numbers and shapes and nature are all woven together.
Okay, I'm definitely seeing a pattern here.
Right.
Numbers, shapes, nature.
It's all connected.
It's all connected. And there's more.
Right.
Right?
Oh, yeah. Philomath even connects the hexapentakes to the flower of life, that spiritual symbol.
Flower of life. Yeah, I've seen that. I never realized it had anything to do with math or geometry.
It's like all these shapes, they're speaking this ancient language,
Okay.
and we're just starting to understand what they're saying.
That is, wow, I'm getting chills just thinking about it. Okay, we got to move on to another mystery, an ancient one that Philomath tries to tackle, the Great Pyramid.
Ah, yes.
Now, I'll be honest, I always just thought it was a super impressive pile of rocks, but Philomath suggests it might be more than that, right?
Much more than that. We're not just talking about a historical landmark here.
Okay.
We could be talking about a treasure chest of, hidden knowledge. I mean, think about it. The dimensions of the pyramid,
Yeah.
they line up with the golden ratio, with pi, all these mathematical constants. That's not just a coincidence.
So are you saying that the ancient Egyptians, they knew all this advanced math?
It's definitely possible. And it gets even more intriguing because Philomath draws this connection between the Great Pyramid and, get this, Leonardo da Vinci.
Da Vinci. Like
Yeah.
the Mona Lisa da Vinci.
The very same. Specifically, his Vitruvian Man, that drawing of a man inside a circle and a square.
Oh, right. Yeah. I never would have connected those two.
It makes sense, though, when you really think about it. Da Vinci, he was obsessed with proportion, with geometry.
Right.
His Vitruvian Man, it's like the perfect embodiment of that.
Okay.
And if the pyramid embodies those same principles, which it seems to,
Yeah.
then it suggests this link between, this ancient structure, human beings, and the entire cosmos. Like, the Great Pyramid is this puzzle.
Okay.
And we're just now starting to put the pieces together.
This is too much for my brain. I love it, but it's a lot.
I know.
Numbers, geometry, ancient mysteries, it's all connected.
All connected.
But wait, there's one more wild connection to talk about.
Oh, no. What?
The harmony between music and numbers. Get ready, because things are about to get really weird. Okay, so we've gone deep into this, secret language of numbers,
Yeah.
right?
We have.
Explored this crazy world of geometry.
Yeah.
Uncovered all these hidden connections across, different cultures and thousands of years.
It's amazing.
And just when you think it can't get any weirder, Philomath throws us this final curveball.
Yeah.
The harmony of the spheres.
The harmony of the spheres. Yep. It's this idea that music, math, they're all connected.
Okay.
That there's a symphony built into reality itself.
Okay, I've heard of that, the harmony of the spheres, but I
Yeah.
always thought it was a metaphor,
Right.
something poets came up with. Philomath takes it literally.
Oh, yeah, they're serious. And they start with something called cymatics.
Cymatics?
Cymatics. Have you ever seen those videos where it's they have a plate
Yeah.
covered in sand and they vibrate it
Yeah.
and the sand makes these crazy shapes?
Yes, depending on the sound.
It's like the sound is creating art.
Exactly. Those are called Chladni figures.
Okay.
And it shows you, right there, sound, shape, totally linked.
Yeah, it's visual. So certain notes make certain shapes.
It's not just random. Specific musical notes, when you play them on these vibrating surfaces, they make these, crazy precise geometric shapes.
Get out of here. No way.
Yeah. It suggests that sound itself has geometry, encoded in the vibrations.
So what music is like, more than just something we enjoy.
Philomath wants us to ask that question, definitely.
It's fundamental to how the universe is structured.
It could be. And Philomath brings us back to an old friend for this.
Oh, no, whoa, not again.
It's Da Vinci.
Da Vinci. But we already talked about him, Vitruvian Man, all that. We did, but there's more to find, Philomath says. They analyzed the Vitruvian Man drawing,
Okay.
and they say there might be hidden geometry in it.
More hidden than the obvious stuff.
More than the square and the circle, yeah. Plus, there are those weird numbers on the sketch.
The 1A, the 114, the 126.
Yep, those are the ones. Philomath says they could be clues.
Because I always wondered about those. They seem so random.
Right. For example, those numbers, they might relate to this old problem, doubling the cube.
What's that?
It's this geometry puzzle. Really, really hard, fascinated mathematicians forever. It's like Da Vinci's leaving us clues.
Okay, so art, geometry, music, ancient math puzzles. Da Vinci's got it all going on.
It's like he could see how everything was connected.
That's amazing. When we started this deep dive, I thought we were just going to be talking about, numbers.
Right.
But this has been... we talk about the secrets hidden in plain sight, the language of shapes, the mysteries of, like, ancient civilizations.
Don't forget the music of the cosmos.
Oh, yeah. And Philomath, it's given us this whole new perspective.
It really does make you think.
It makes you question everything. I don't think I could look at a number the same way again.
Welcome to the club.
So, to all of you listening, if you're like us, if you're fascinated by these hidden connections, these patterns in the universe,
It's incredible.
check out Philomath. You might be surprised what you find. Until next time, keep exploring, keep questioning, keep diving deep.